Okay, 1991 Mechanics 3. The two blocks 1 and 2 shown above have masses m and 2m respectively. Block 2 has an ideal massless spring attached to one side. When block I is placed on the spring as shown, the spring is compressed to distance d at equilibrium. Express your answer to all parts of the question in terms of the given quantities and physical constants. Part A, determine the spring constant. Alright, so for part A, you can start out by saying F net equals 0 because it's in equilibrium and the top block isn't moving on the spring. So you can also draw a free body diagram and say that mg and kx are equal because there is no net force. So mg equals kx. And you know you can replace x with d, so we'll do that. And then you divide that out and you get k equals mg over d. So that's the first part. It's pretty straightforward. The next part, the spring compression, is a maximum when the blocks have the same velocity. Briefly explain why this is so. This is referring to later the two blocks are on a frictionless horizontal surface. Block 2 is stationary, block 1 approaches with a speed v0 as shown above. That's just that. And that's question B. We're just going to try and find the compression maximum. And we're going to do that by first saying that the initial momentum is equal to the final momentum, which is going to be m v0 equals 3m v final, because you have 1m plus 2m, the two weights of the blocks. And then you can do some conservation of energy. 1/2 mv0 squared equals 1/2 kx squared, that's your electric potential, plus 1/2 3m vf squared. That is your kinetic energy of the blocks once they're together, and this springs at maximum compression. And next, what you can do is, if you go back to this equation for the momentum, you can solve for Vf to sub it out, so you can put it into this equation and then solve for x. So what we're going to do is we're going to cancel out the m's because they're on both sides of the equation. So we're going to have v0 equals 3vf, so v0 over 3 equals vf. And then we're going to plug that in here. So okay, and then you can distribute this and you're going to get v0 squared over 9, but then this 3 is going to cancel here, so you can just rewrite that like this. Because your 3 just canceled out and your top v0 is going to be squared. And that's that. And now what you're going to do is you're going to try and solve for x. And we're going to start doing that by putting all the mv naughts on one side. And it's really easy to do that if you just kind of put them all over one denominator. So we'll start out on a new piece of paper because it's getting cramped. It's going to start out with mv0 squared over 2 equals 1/2 kx squared plus mv0 squared over 6. So you just brought the 2 and the 3 together from before, and it's going to be 6. So this is that, and so what you're going to do really fast is you're going to, so you have 1/2 times 6 over 6, right? Because you're going to want to get this common denominator, and 6 over 6 is the m value here, and 1/2 is the initial from the kinetic energy equation, which is going to simplify down to 3/2. Or no, I swear I can math. It's going to simplify down to 3 over 6, which is what we're going to need in order to have our common denominator. So it's going to be 3m v0 squared over 6 is equal to 1/2 kx squared plus m v0 squared over 6. And then you're just going to subtract this quantity from both sides. Right, that'll cancel. And this is, you just treat it like a regular fraction. So you're going to get 2 mv naught squared over 6 equals 1/2 kx squared. Alright? And then you just continue through solving for x. Multiply both sides by 2. 4. Right? And then we know k from before. We know that k is equal to mg over d. So now you can sub that in. And so you can cancel out the m here and the m there. And you're just going to move this variable over there, and you're going to divide by this variable and get 4 d v naught squared over 6g equals x squared. Simplify this fraction to 2 and 3, and then you take the square root of both sides, right? Square root, and then you're going to get v naught square root of 2d over 3g, and that is your x value. Alright, so part B just asks for an explanation of part A, and you can say since the system is at equilibrium that f net equals 0, therefore mg equals kx, and then the rest is just shown right there in that step in part A. So d is just the velocity of block 2 once they've separated again. So you're going to start out with conservation of momentum. mv naught equals mv1 plus 2v2. You're just 2mv2, sorry. You're just separating out the 3 mv2 that you had in the previous equation. And then you can cancel all these m's and get v naught equals v1 plus 2v2. And eventually you're going to need v1, so you might as well just sub for that now. So you're going to get v1 is equal to v naught minus 2v2. And this is going to come in handy in a second, because now we're going to switch to energy. Alright, so this was all momentum. And now we're switching to energy over here. So we're going to start off with the same equation we had before. But instead of putting v1 squared here, you're going to sub in the term we just had here. So v naught minus 2v2 squared plus 1/2 2m v naught v2 squared. Sorry about that. Then you're just going to FOIL this out, which is going to turn out to 1/2 m, FOIL, 1/2 m v naught squared minus 4 v naught v2 plus 4v2 squared. Alright. That's going to be plus 2v squared on the outside, because you're just going to do some canceling here of the m and the 1/2, and you can cancel these two. I just didn't do that before, so these go away. And then you can just do that over again. So it's v naught squared minus 4v naught v2 plus 4v2 squared plus 2v2 squared. And that all equals v naught squared. Right? Kind of looks like momentum now. So then what you're going to do is you're going to just start solving for v2. So those cancel. 0 equals negative 4 v naught v2 plus 6 v2 squared, just adding these two. And then you're just going to move that over to one side. Right? Easy enough. And then this cancels with one of these, and you get 4v naught equals 6v2 2, and then you just divide, because you're looking for the ratio of V0 to V2, over 6. You get V2 is equal to 4/6 V0, or 2/3 V0. Awesome.